Hello and welcome back to the sleep science space. I'm really glad you made it here tonight. Maybe your day has been heavy, or maybe you're simply someone who prefers drifting off while thinking about planets, moons, and the quiet mathematics of the cosmos. However, you arrived, this slow journey is yours to settle into. For now, there's nothing left to do. Let your shoulders loosen. Let your breath fall into a soft rhythm. Let your thoughts spread out like stardust until you feel as though you're hovering just above the world you know. Tonight, we're going to wander through the solar system together, unhurried, weightless, and carried by curiosity. We won't travel in straight lines. We'll follow gentle arcs through shimmering rings over cratered surfaces, past worlds wrapped in storms and oceans hidden under ice. We'll explore not through equations, but through the stories written into magnetic fields, strange tilts, ancient sunlight, and moons that glow where no daylight reaches. Every orbit holds something unexpected, something wondrous. And if these quiet cosmic explorations give you space to breathe or help you drift towards sleep with a little more ease, feel free to tap the like button or subscribe. It helps more dreamers find this little corner of the night. But for now, just let yourself relax as our journey begins. Neptune's winds can outrun sound. Though Neptune circles the sun at a distance so vast it borders on darkness, its atmosphere is anything but still. High above its cloud tops, winds roar at more than 2,000 kilometers per hour, fast enough to break the sound barrier on Earth. Imagine a storm moving 5 times faster than a passenger jet. Scientists think these violent currents are powered by heat rising from deep within the planet. Heat that refuses to fade, even in the cold outer reaches of the solar system. Neptune's pale blue clouds hold the scars of these storms. Huge dark spots that drift like shadows across a frozen giant, forever in motion. Mars carries a canyon the size of a continent. Near the Martian equator lies a wound so enormous it defies comparison. Valles Marineris stretches over 4,000 kilometers, long enough to cover the entire width of the United States, and plunges 7 kilometers down in some places. It makes the Grand Canyon look like a fracture in stone. Its origins are still debated, but many believe it formed when Mars's crust split apart as volcanic forces pushed and pulled beneath the surface. Over time, landslides, erosion, and chemical weathering widened the rift into the colossal scar we see today. It is a monument to a world that once shifted and groaned with geological energy, now long gone quiet. Venus lives without a planetary shield. Although Venus resembles Earth in size and rocky composition, it lacks one of our planet's most important defenses, a global magnetic field. Earth's molten outer core churns like a vast electric engine, generating a protective bubble that deflects solar radiation. Venus, on the other hand, appears to have a core that barely stirs or has grown too solid to create the same effect. Without this magnetic shield, solar wind strips particles from its atmosphere, bit by bit, contributing to the planet's transformation into a superheated high-pressure world. Venus may once have resembled Earth, but without protection, it became something far more hostile. Diamonds may fall as rain on Uranus and Neptune, far beyond the warmth of the inner planets deep within the ice. Giants' carbon faces conditions so intense, temperatures of thousands of degrees, and crushing pressure that it may crystallize into diamond. Experiments on Earth suggest that methane in the planet's atmospheres could break apart, allowing carbon atoms to compress into shimmering crystals that drift downward like glittering rain. Some scientists even imagine oceans of diamond slush or solid diamond cores hidden below. Out there, in the dark storms, may be sculpting gems on a scale no human hand could ever craft. Deep inside the atmospheres of Uranus and Neptune, the pressure rises to overwhelming levels, and temperatures soar far beyond anything their icy surfaces suggest. In these hidden layers, something astonishing may be happening, storms that create diamonds. Both planets contain abundant methane, and under crushing pressure, the methane molecules can break apart. The carbon inside them drifts downward, squeezed tighter and tighter until it crystallizes. What begins as scattered carbon atoms may transform into glittering shards, falling like tiny gemstones through the planet's deep blue haze. Experiments on Earth have recreated the process, hinting that these distant giants could be home to diamond rain, crystalline storms, drifting in the dark where sunlight never reaches. Earth remains the only world we know with moving crustal plates. Among the many things that set Earth apart, its shifting continents may be the most quietly powerful. Our planet's crust is broken into immense plates that glide slowly over the mantle. They collide and lift mountains into the sky, pull apart to form oceans, and recycle carbon deep underground, helping regulate climate across millions of years. No other planet yet shows this kind of restless geology. Mars and Venus bear ancient scars of volcanoes and fractures, but they no longer churn and breathe the way Earth does. Our plate tectonics may be one of the deep reasons life can flourish here, keeping the world's temperature and chemistry in long term balance. Some asteroids travel with tiny companions. Although we often imagine asteroids drifting alone through the void, many are not solitary at all. Some have their own miniature moons, small rocks, caught by gravity or formed in tandem with their parent body. The first one discovered was Dactyl, a little moon orbiting the asteroid Ida photographed unexpectedly by Galileo in 1993. Since then, astronomers have found many more double asteroids, triples, and systems where two bodies twirl around each other like a slow celestial dance. Even in the emptiness of space, gravity finds ways to knit objects together. Mercury is surrounded by a thin whisper of atoms, not a true atmosphere. Earth's sky is thick with air, but Mercury's air is almost nothing at all. Instead of an atmosphere, it carries an exosphere, a fragile haze made of atoms knocked loose from its surface by solar wind and micrometeoroid dust. These particles drift above the planet in a near vacuum, rarely colliding, always escaping into space. Sodium, potassium, oxygen, faint traces that shimmer invisibly around the planet like a ghostly veil. Mercury's gravity is too weak to hold on to them for long, So the process repeats endlessly, atoms blasted away, drifting outward, replaced by new ones cleaved from the scorched ground. The sun sheds mass at an incredible rate. Every second, deep in its core, the sun fuses hydrogen into helium, turning matter into pure energy. In doing so, it loses over 4 million tons of mass every second mass that becomes sunlight warmth and the glowing energy that streams across the solar system. You feel that loss on your skin every day. Every sunrise is powered by the sun, sacrificing a little more of itself to keep our world lit and alive. Deep inside the sun, hydrogen nuclei collide and merge into helium, releasing immense amounts of light and heat. That radiant energy travels outward through layers of plasma before spilling into space, bathing the solar system in warmth. It stirs the winds of planets, fuels weather patterns, and makes life on Earth possible. Although the sun loses only a tiny fraction of its mass each second, the total loss over billions of years becomes significant. One day, when its hydrogen reserves run low, the sun will swell and transform. But for now, it burns with steady brilliance, giving away a little of itself moment by moment. Saturn's rings are slowly slipping away. Those elegant bands of ice and dust may look eternal, but they are fading. Saturn's gravity and magnetic field tug on the particles, drawing them inward in a phenomenon known as ring rain. Ice grains charged by sunlight spiral down toward the planet, dissolving into its atmosphere grain by grain. Data from the Cassini mission suggests the rings are surprisingly young, likely no more than 100 million years old, and may disappear within a few hundred million years more. What we see today is a temporary masterpiece, a cosmic sculpture destined to dissolve back into the planet that holds it. Mars is home to storm winds that swallow an entire world. The red planet's thin atmosphere is capable of generating dust storms so enormous they can wrap the globe in a copper colored haze. These storms can endure for weeks or months, blotting out sunlight and turning day into a dim orange twilight. Because the dust is extremely fine, it lingers in the air for long periods, driven by temperature differences and vast winds. Some storms begin as harmless whirlwinds, but grow as heat and wind amplify one another. In 2018, such a storm darkened Mars so thoroughly that the Opportunity rover could no longer charge its batteries. Even without oceans or weather like Earth's, Mars remains an active, dynamic world shaped by its own restless atmosphere. Europa may hide a global ocean beneath its frozen skin. Jupiter's icy moon, smooth and pale, conceals an astonishing secret. Beneath its cracked shell of frozen water, scientists believe an enormous ocean lies in darkness, possibly deeper than every ocean on Earth combined. Jupiter's tidal pull stretches and flexes Europa's interior, generating enough heat to keep the water liquid. The moon's surface is streaked with long scars where ice plates shift and break, hints of movement below. Magnetic measurements and chemical signatures gathered by spacecraft strongly support the existence of salt water beneath the ice. What makes Europa truly mesmerizing is what that ocean might contain. A world warmed from within, sealed off from sunlight, yet potentially rich in energy and chemistry. If life exists beyond Earth, Europa's hidden sea is one of the most promising places to look. Mars carries a volcano so tall it dwarfs Everest. Olympus Mons rises nearly 22 kilometers above the Martian plains, close to 3 times the height of the tallest mountain on Earth. Its base is so wide that if you placed it in the United States, it would blanket most of New Mexico. This enormous shield volcano grew over countless eruptions, each one adding another layer of rock. Because Mars has no drifting tectonic plates, the magma chamber beneath Olympus Mons stayed in the same position for millions of years. On Earth, that same process creates chains of islands. On Mars, it built a single Titan. Today, the volcano sits silent beneath the thin Martian sky, its slopes so gentle you could walk for hours without realizing you were climbing a mountain taller than any found on Earth. Saturn's rings stretch wide, but they are impossibly thin. Across nearly 300,000 kilometers, Saturn's rings form a shimmering halo around the planet, yet the entire structure is usually no thicker than a few dozen meters. In many regions, they're thinner than a city block. The rings are made from countless fragments of ice, some no bigger than dust particles, and others the size of small buildings. When sunlight hits them just right, they almost vanish like a sheet of glass turned edge on. Their razor thin structure is shaped by Saturn's gravity, by collisions among the ring particles, and by the guiding pull of tiny shepherd moons. From far away, the rings look like a solid band. Up close, they are a drifting snowfall of ice fragile flat and breathtakingly delicate. Earth is the heaviest world for its size. Among all the planets in the solar system, Earth has the highest overall density. Even though Jupiter is vastly larger, Earth packs more mass into each cubic centimeter. That density comes from our iron-rich core and the layered mantle that surrounds it. This compact structure helps power the magnetic field that shields the planet from solar storms. Deep inside Earth, molten metals churn and rotate, creating an invisible protective bubble around our world. Our gravity, our tectonics, our ability to hold an atmosphere all are shaped by this dense and complex interior. The sun hums with hidden music. Though space is silent, the sun vibrates constantly. Waves of pressure move through its fiery layers, rising and falling like the resonance inside a vast musical instrument. These vibrations occur far below the range of human hearing, but scientists can detect them by watching how the surface gently shifts and pulses. The field that studies these rhythms is called helioseismology. By following how sound waves bounce through the sun, researchers uncover details about its internal structure, its temperature density, and layers, much as seismologists study Earth by tracking the echoes of earthquakes. The sun, from its burning core to its glowing surface, is always singing. We simply can't hear the song. These vibrations inside the sun reveal shifting currents, magnetic pulses, and the hidden choreography of fusion deep beneath its glowing surface. In a sense, the sun is never silent. It murmurs through motion, whispering its inner structure through waves that ripple outward like a quiet cosmic heartbeat. Venus turns the wrong way. Among the planets, Venus keeps its own strange rhythm. Rather than spinning in the same direction as most worlds in our system, it rotates backward, a motion astronomers call retrograde rotation. If you could stand on its surface, the sun would creep up from the west and sink slowly toward the east, and that day would stretch on endlessly. One Venusian rotation lasts longer than a Venusian year. 243 Earth days for a single turn. No one is completely sure why. Perhaps a colossal ancient collision jolted the planet into this reversed spin, or tidal forces from the sun gradually tugged its rotation into a slow backward drift. Whatever the cause, Venus spins to its own quiet, unusual beat. Jupiter keeps a kingdom of moons. The largest planet in our cosmic neighborhood is not alone. Jupiter is orbited by more than 90 moons, an entire miniature solar system bound to its gravity. Its four massive companions, Io, Europa, Ganymede, and Callisto, were first seen by Galileo in 1610, and each one is a world with its own story, erupting volcanoes, hidden oceans, icy landscapes. Beyond these giants lies a swarm of small, irregular moons, many captured from wandering objects. Some of them move backward, some wobble in strange orbits, and some are little more than tumbling boulders. Around Jupiter, even the tiniest worlds find a place to drift. Mercury guards ice in places the sun never reaches. Though Mercury scorches under sunlight and freezes in darkness, the last thing you'd expect on such a blistering world is water ice. Yet at its poles, inside deep craters where sunlight has never touched temperatures, remain frigid enough for ice to survive for millions of years. These permanently shadowed pockets act like natural vaults, shielding frozen water from the sun's relentless heat. Radar observations from spacecraft revealed bright reflections, signatures of ice hiding in the darkness. The water may have come from comets or ancient volcanic steam preserved on a planet that otherwise burns with heat. Pluto's heart may conceal a buried ocean. The pale heart-shaped region on Pluto, called Sputnik Planitia, might be more than a charming landmark. Evidence from NASA's New Horizons mission suggests that beneath its frozen crust lies a deep subsurface ocean kept liquid by heat from radioactive decay and thick insulating layers of ice. The basin's weight and the strange patterns on its surface hint that Pluto, though distant and frigid, may still be geologically alive. Even at the edge of the sun's light, a hidden ocean may be slowly stirring in the dark. The asteroid belt is mostly empty space. Movies often show the asteroid belt as a dense field of tumbling boulders. But the truth is far more serene. The region between Mars and Jupiter is vast, and its rocky bodies are separated by enormous distances, millions of kilometers of emptiness between them. You could fly through the belt without ever seeing a single asteroid. Only gravity binds this scattered family of stones, remnants from a planet that never formed. It is less a chaotic maze and more a quiet, lonely expanse of drifting worlds. A spacecraft drifting through the asteroid belt would almost never meet a solid obstacle. Despite its reputation, The belt is mostly emptiness, quiet stretches of space, with lonely fragments scattered far apart. Altogether, the entire belt weighs less than 5% of our moon. Its largest residents, like Ceres and Vesta, hold much of that mass. The rest is a gentle rain of ancient rubble, leftovers from a world that never formed. They are the solar system's early building blocks, preserved in silence for billions of years. Uranus doesn't spin the way other planets do. Most planets rotate like spinning tops, leaning slightly but staying upright. Uranus, however, is almost lying on its side. With an axial tilt of about 98 degrees, it essentially rolls around the Sun. During parts of its long orbit, one pole faces the Sun, directly bathing in sunlight for 42 continuous years. Then it plunges into 42 years of unbroken night. Scientists still debate what toppled Uranus, perhaps a colossal collision or a slow gravitational nudge over time. Whatever the cause, its sideways orientation creates one of the most unusual seasonal rhythms in the solar system. Jupiter hides deadly radiation beneath its beauty. Around this giant planet swirls an enormous magnetic field, the strongest of any world we know. Trapped within it are belts of intense radiation, far more powerful than Earth's Van Allen belts. These charged particles spiral around Jupiter, forming an invisible but lethal halo. Any unshielded spacecraft would be damaged within hours. Even Jupiter's moons must endure this harsh environment. Radiation can alter their surfaces and may shape their potential for hosting life. Jupiter may be majestic, but it is wrapped in a dangerous, unseen storm. The Sun holds almost everything. At the center of our system, the Sun claims nearly all of the mass, about 99.8% of everything that exists here. All the planets, moons, asteroids, comets, and drifting dust combined make up barely a fraction of the remainder. This immense mass is what gives the Sun its power. Gravity squeezes hydrogen in its core until fusion ignites, releasing the light and warmth that spill across the solar system. From the glow on Earth's oceans to the shimmer of Saturn's rings, nearly all energy begins in the Sun's heart. There are far more dwarf planets than the 8 we call planets. Beyond Neptune lies a distant realm filled with icy worlds, hundreds, perhaps thousands, many large enough to be round, fitting the definition of dwarf planets. Pluto is the most famous, but it is only one member of a vast hidden population. Others like Eris Haumea and Makemake share this status, and many more continue to be discovered in the Kuiper Belt and even farther out. These small, frozen spheres are ancient relics from the solar system's youth, untouched by geology and time. While the classic planets number just 8, the family of dwarf planets may stretch deep into the darkness, a quiet crowd orbiting in the farthest reaches. Though these distant worlds drift in the cold shadows each one carries, clues to how our solar system first came together. They are the quiet archivists of cosmic history, holding memories of the swirling disk of dust and ice from which everything we know was born. A day on Venus lasts longer than its year. Venus rotates so slowly that its surface barely turns. One full spin takes 243 Earth days, while a trip around the Sun takes only 225. That means the planet completes an entire orbit before it finishes a single rotation. Its slow spin helps create a world of unbearable heat and suffocating pressure where the atmosphere grows thick like syrup and temperatures rise high enough to liquefy metal. Venus is wrapped in clouds of sulfuric acid, its sunlight dim and distorted, its days long, endless, and strangely dreamlike. Titan has lakes made of methane. Saturn's largest moon looks familiar at first glance, its landscapes shaped by rivers, lakes, and long twisting shorelines. But the liquids carving Titan's surface aren't water, they are methane and ethane flowing in cycles much like Earth's rain. Thick orange haze surrounds the moon, forming storms and weather patterns stitched together from alien chemistry. Some of Titan's dark seas stretch for hundreds of kilometers, and deep beneath its frozen shell, scientists suspect a hidden ocean of liquid water may slosh in the dark. Titan is a mirror of Earth, but one built from cold hydrocarbons instead of warm oceans. The moons of Mars may be captured asteroids. Phobos and Deimos orbit Mars like lopsided stones tossed into the sky. Small, jagged, and irregular, they resemble wandering asteroids more than true moons. Many scientists believe that long ago, Mars's gravity caught these objects and pulled them into orbit. Their odd shapes and lightweight interiors support this idea. Phobos slowly spirals inward each year and will eventually crumble or fall, while Deimos drifts gently outward. These two moons circle Mars like relics of an earlier age, silent witnesses to the planet's more chaotic past. Jupiter glows with its own heat, even far from the Sun. Jupiter radiates energy into space. It shines because of the heat left over from its birth, a warm afterglow from when the young planet collapsed under its own gravity. Over billions of years, Jupiter has continued to contract, just slightly releasing additional warmth into its swirling atmosphere. This deep internal heat powers the planet's colossal storms, from the turbulent belts of clouds to the great red spot itself. In infrared light, Jupiter glimmers like an ember beneath layers of gas. It is not a star, but in another universe, with just a little more mass, it could have been. Neptune was discovered through math. Before anyone had ever seen it, Neptune revealed itself through the subtle tug of gravity. Astronomers noticed that Uranus wasn't following its expected path, something unseen was pulling on it. Two mathematicians working separately calculated where this hidden world must be. When telescopes were pointed to that exact patch of sky, Neptune appeared. It was the first planet discovered not by sight, but by equations, a world found through logic prediction and the quiet language of gravity. Saturn's North Pole has a hexagon. At the top of Saturn, a strange, mesmerizing shape spins endlessly, a six-sided jet stream wider than Earth. This massive hexagon rotates like a perfect geometric storm, its edges straight as if drawn by a cosmic architect. Winds circle through it at hundreds of kilometers per hour, and yet the pattern remains stable, holding its shape through decades of observations. Scientists still puzzle over how such a structure forms, But inside Saturn's swirling atmosphere, the hexagon turns on and on, an elegant mystery etched into cloud. Scientists believe the hexagon forms from the strange way Saturn's upper atmosphere rotates with streams of air moving at different speeds and locking into a stable standing wave around the pole. In laboratory tanks filled with swirling fluids, similar polygon shapes appear when rotation reaches just the right balance. That a perfect geometric form can arise naturally in a gas giant's atmosphere still feels surreal, an elegant reminder that even chaos can curve itself into order. The sun's atmosphere is hotter than its surface. It sounds impossible, but the visible surface of the sun, its photosphere, sits at around 500 degrees Celsius, while the outer atmosphere above it, the glowing corona, soars to temperatures of more than 1 million degrees. For decades, scientists have tried to understand how heat flows upward into regions that should be cooler. Some think waves of magnetism rising from deep inside the sun snap and ripple outward, depositing bursts of energy. Others point to countless tiny flares, nanoflares, that erupt too small to detect individually, but together heat the corona to extreme temperatures. Whatever the mechanism, the result is a halo of scorching, mysterious fire surrounding a surface far cooler than the space above it. The Kuiper Belt is full of icy worlds. Beyond Neptune lies a vast ring of frozen remnants from the early solar system, a region known as the Kuiper Belt. Billions of icy bodies drift there: Pluto, Eris, Haumea, Makemake, and countless smaller worlds, ancient leftovers that never grew into full planets. Some are round and massive enough to be classified as dwarf planets. Others are irregular, tumbling through the dark like forgotten fragments of creation. The Kuiper Belt is the colder, lonelier cousin of the asteroid belt, but it holds far more primordial ice and untouched history. Out there, sunlight is only a faint whisper, and the objects that remain are fossils of the solar system's earliest days. The Oort cloud may stretch a full light year from the sun, far beyond even the Kuiper belt at distances almost impossible to imagine. Scientists believe a vast spherical shell of icy bodies surrounds the sun. This hypothetical region, the Oort cloud, may extend nearly a light year in every direction. It is thought to be the birthplace of long period comets, objects that appear suddenly from deep space with orbits spanning thousands or even millions of years. These frozen wanderers are only loosely held by the sun's gravity. A passing star or the tidal pull of the galaxy could easily nudge one inward. If the Oort cloud truly exists, it marks the final ghostly boundary of the sun's reach. Io is the most volcanic world in the solar system. Jupiter's moon, Io, is a world in constant upheaval. Its entire surface is mottled with yellow black and red from sulfur and molten rock reshaped again and again by powerful eruptions. Some volcanic plumes blast hundreds of kilometers into the vacuum of space. The source of this furious activity is tidal heating. Io is squeezed and kneaded by Jupiter's immense gravity and by the gravitational tug of war with nearby moons. All that internal friction transforms into heat, melting rock, and driving Io's violent geology. Where Earth's crust slowly cools over time, Io's surface remains young, hot, and endlessly reborn. Triton orbits backward around Neptune, Neptune's largest moon. Triton defies typical celestial behavior. Instead of orbiting in the same direction as its planet's rotation, it moves backward, a clue that it didn't form beside Neptune at all. Most likely, Triton was once a dwarf planet sized object wandering the Kuiper Belt before Neptune captured it. The capture would have been catastrophic, possibly scattering or destroying Neptune's original moons. Today, Triton remains geologically active, with cryovolcanoes that erupt icy plumes and a thin, shifting atmosphere that freezes and thaws with the seasons. A cold world traveling in reverse, quietly rewriting the rules of moon formation. Earth's moon is unusually large. When compared to the planet it orbits, Earth's moon is enormous, far larger than typical moons found elsewhere in the solar system. Most moons are tiny companions, dwarfed by their host planets, but ours is more than a quarter the size of Earth itself. Its presence stabilizes Earth's tilt, shapes our tides, and may have even influenced the development of life. Its origin, most likely from a colossal impact early in Earth's history, makes it a singular companion, a world sized moon circling a world sized planet, bound together by the memory of an ancient collision. No other rocky world in our solar system carries a satellite as large, relative to its own size, as the moon does for Earth. Our moon spans roughly one quarter of Earth's diameter, a proportion more commonly seen in dwarf planet systems than in full sized planets like ours. Most researchers agree that the moon was born from violence. A Mars sized body struck the early Earth, ejecting a halo of glowing debris that slowly gathered into the sphere we now see in the night sky. That ancient impact bound Earth and Moon into a single evolving system. Over billions of years, the Moon has shaped our tides, steadied our climate, and helped stabilize Earth's wobbling axis. It isn't just our companion, it's a relic of catastrophe, a monument to destruction that ultimately fostered life. Planetary orbits are not perfect circles. Although illustrations often show the planets tracing smooth rings around the sun, their paths are actually ellipses, slightly stretched shapes with the sun resting off to one side. Because of this, each planet has a moment when it sweeps closest to the sun, called perihelion, and another when it drifts farthest away, known as aphelion. For some planets, the difference is hardly noticeable, but for Mercury and Pluto, the change is stark. These elongated paths subtly shape seasons, influence temperature, and even alter the speed at which a planet travels along its orbit. Johannes Kepler first described these elegant ellipses in the 1600s, reshaping our understanding of celestial motion forever. Some comets come from the edge of interstellar space, long period comets. The ones that return only once every few thousand years likely begin their journey in the distant Oort cloud, a spherical shell of frozen bodies nearly a light year from the sun. These icy travelers drift in darkness for ages, barely held by the sun's gravity until something disturbs them, the gentle tug of a passing star, the slow pull of the Milky Way, or the subtle reshuffling of the cloud itself. Once nudged inward, they plunge toward the sun, warming and unfurling radiant tails that stretch across the sky. For a brief moment, we see them, the oldest untouched material in the solar system, before they vanish again into the deep. The sun will one day become a white dwarf. Like all stars, the sun has a life cycle. About 5 billion years from now, its core will run out of hydrogen fuel and begin to swell into a red giant, expanding outward until it engulfs the inner planets. When that phase ends, the sun will cast off its outer layers, forming a delicate, glowing shell known as a planetary nebula. What remains will collapse into a white dwarf, a hot, Earth sized core made mostly of carbon and oxygen. It will fade slowly over trillions of years, cooling into a silent ember. This will be the sun's final identity, not the brilliant star that warms our days, but a tiny pale remnant floating in the dark. Mars has seasons much like Earth. Although Mars is colder and its atmosphere thin, the red planet still experiences spring, summer, autumn, and winter. Its axial tilt, about 25 degrees, is close to Earth's, causing sunlight to shift across the hemispheres throughout the Martian year. Seasons on Mars unfold slowly because the planet takes nearly twice as long as Earth to complete an orbit. These shifts reshape polar ice caps, alter air pressure, and fuel dust movements across the plains. The rhythm is familiar, yet the world it plays out on is stark quiet and touched by cold. Ganymede is the largest moon in the solar system. Among all the moons orbiting all the planets, Ganymede, one of Jupiter's great satellites, stands unrivaled in size. It's even larger than the planet Mercury, stretching more than 5,000 kilometers across. Within this enormous world lies an rocky core, a shell of ancient ice, and strong evidence for a hidden ocean locked beneath its frozen surface. Ganymede even has its own magnetic field, something no other moon possesses, hinting at a restless interior shaped by Jupiter's gravity and its own internal heat. Scarred with grooves, ridges, and plains, it is a world in its own right, quietly circling the giant that holds it. Ganymede is remarkable for many reasons, but one trait sets it apart from every other moon in the solar system. It possesses its own magnetic field. This invisible shield, generated deep within its interior, creates faint auroras that shimmer at its poles, soft ribbons of light, glowing in a whisper-thin atmosphere. Beneath its icy crust, scientists suspect there may be not just one ocean, but several layers of liquid water stacked between frozen shells. If true, Ganymede could hold more water than all of Earth's oceans combined. Yet despite its size and complexity, it remains a silent, shadowed world, circling forever inside Jupiter's vast magnetic embrace. Pluto sometimes ventures closer to the Sun than Neptune. Because Pluto follows an elongated oval-shaped orbit, it occasionally slips inside Neptune's path. Between 1979 and 1999, Pluto actually became the eighth planet from the Sun instead of the ninth. But the two worlds never come close to colliding. Their orbits are locked in a precise resonance for every 3 loops Neptune makes. Pluto completes exactly 2. This gravitational choreography keeps them safely separated, a cosmic dance timed over millions of years, a reminder that even distant icy worlds follow elegant patterns written into the fabric of the solar system. The sun flips its magnetic field every 11 years. Roughly once each decade, the sun undergoes a dramatic transformation. The north and south magnetic poles swap places. This magnetic reversal drives the solar cycle a rhythm that increases and decreases the number of sunspots, flares, and coronal mass ejections. During solar maximum, the sun grows stormy and unpredictable. During solar minimum, it becomes quieter and calmer. These changes ripple outward, influencing Earth's upper atmosphere, satellite behavior, and the auroras that shimmer near the poles. The sun's magnetism doesn't stay still, it pulses, shifts, and breathes like a giant glowing heart. Planetary alignments do not cause disasters on Earth. Although stories and myths often claim that the planets lining up in the sky can trigger earthquakes, storms, or floods, science tells a quieter truth. The gravitational pull of the other planets on Earth is incredibly small, far weaker than the influence of our moon or even the sun. Even during rare alignments, their combined pull is barely noticeable. Alignments are beautiful to watch and fascinating to calculate, but they are harmless, a graceful arrangement of planets drifting through space, not a warning or a threat. Leaving the solar system takes decades. Escaping the sun's grasp is an astonishingly slow and patient journey. The Voyager spacecraft, launched in the late 1970s, have only recently crossed into interstellar space, beyond the bubble where the solar wind fades into the galactic medium. It took them more than 40 years racing outward at over 60,000 kilometers per hour to reach that distant frontier. Along the way, they passed every planetary orbit, slipped through the Kuiper Belt, and continued into the deep. Even now, their instruments still whisper data back to Earth. Each carries the golden record music greetings and sounds of our world. They are humanity's quiet messengers drifting into the endless dark. Earth's magnetic field protects us from space radiation. Surrounding our planet is a powerful but invisible shield created by the swirling motion of molten iron in Earth's outer core. This magnetic field deflects charged particles from the solar wind, preventing them from stripping away the atmosphere. Without it, Earth might resemble Mars, a cold world whose air was slowly peeled away by the sun. Our magnetic field forms a protective cocoon, sheltering oceans, air, and life itself. Even now, as you rest, it stands guard, turning aside storms of radiation so silently that we rarely notice its presence at all. The magnetic field that wraps around Earth not only shields us from radiation, but also guides charged particles toward the poles where they collide with atmospheric gases and bloom into auroras, soft, shimmering curtains of green, red, and violet. These lights ripple silently across the sky, a luminous reminder of the invisible forces protecting our world. Earth's magnetosphere is never still. It flexes, shifts, and responds to the sun, forming a living shield, essential for sustaining both climate and life over geological time. The moon is slowly drifting away from us. Each year, it slips about 3.8 centimeters farther into space. This gentle retreat is caused by the gravitational tug of war between Earth and the Moon. As our planet's oceans bulge and shift under lunar gravity, they push back, transferring energy outward and nudging the Moon into a wider orbit. Long ago, the Moon hung much larger in the sky, dominating the horizon. As it continues to recede, Earth's days lengthen ever so slightly, and solar eclipses grow rarer and less dramatic. Far in the future, total eclipses will vanish entirely. The sky is changing quietly, patiently, while we hardly notice. The Kuiper Belt holds icy worlds that shine like mirrors. At the frozen edge of the solar system, distant bodies drift through darkness with startling brightness. Objects like Haumea, stretched into a spinning football like shape, are coated in crystalline ice that glints under faint sunlight. Eris, even farther out, reflects so much light that it gleams almost like polished metal, brighter than fresh snow on Earth. These reflective surfaces may come from cryovolcanic eruptions, collisions, or strange chemical processes on their frozen crusts. Out where the sun is only a pale star, these worlds squint sharply like cold mirrors suspended in silence. Enceladus sprays water into space. Though small and icy, Saturn's moon Enceladus hides one of the most magnificent processes in the solar system. From cracks near its south pole, towering jets of water vapor and icy grains burst upward, reaching hundreds of kilometers into space. These plumes are driven by tidal heating deep below the surface, friction created as Saturn's gravity flexes the moon's interior, keeping a global ocean warm and liquid. Inside the geysers, spacecraft have detected organics, salts, and signs of hydrothermal reactions, the same kind that support life around Earth's deep sea vents. Some of this water escapes and refreshes Saturn's E-ring, stitching moon and planet together through a constant exchange of ice. Some asteroids are loose piles of rubble. While many imagine asteroids as solid chunks of rock, countless others are fragile clusters of boulders, gravel, and dust scarcely held together by gravity. Known as rubble piles, these objects form when catastrophic impacts shatter larger bodies and the fragments slowly settle back into loose clusters. They can change shape, harbor large hollow spaces, and even shift under gentle pressure. Spacecraft missions such as Hayabusa 2 and OSIRIS-REx have revealed their porous, delicate nature, ancient ruins from the solar system's violent beginnings, drifting quietly through space. Mercury carries a core far larger than expected. Though Mercury is the smallest rocky planet, its internal structure is dominated by a massive iron core that makes up roughly 80% of its radius. Why such an enormous metallic center exists remains uncertain. Perhaps a colossal impact stripped away its outer layers long ago, or maybe Mercury formed close to the newborn sun, where intense heat caused lighter materials to evaporate. Whatever the cause, the result is a world with a thin crust, an oversized core, and a faint magnetic field, a compact relic forged during the turbulent dawn of the solar system. Venus has no moons at all. Among the rocky worlds, only Mercury and Venus orbit the Sun alone, without natural satellites to accompany them. Venus's lack of moons remains a mystery. Some theories suggest it once had one or more that were lost after gravitational encounters or ancient collisions. Others think its slow backward rotation may have prevented stable moon formation altogether. Whatever the history, Venus drifts through space in solitary silence, glowing beneath dense clouds with no companion circling beside it. While Mercury's closeness to the Sun may explain why it travels alone, Venus remains a quiet mystery. It's nearly the same size as Earth, yet Earth has a large stabilizing moon and Venus has none. Some scientists believe Venus may once have possessed a moon that slowly spiraled inward and fell back into the planet, erased by gravity and heat. Others suggest it could have been lost to a colossal ancient impact. Another idea points to Venus's peculiar rotation, slow, reversed, and turbulent, possibly preventing any stable satellite from surviving. Whatever the reason, Venus moves through the sky utterly alone, wrapped in clouds brilliant from afar, yet with no companion to soften its long twilight. Most moons in the solar system gather around the gas giants, while Earth holds one steady partner and Mars keeps two tiny pebble like moons nearby. The outer giants are surrounded by entire families of satellites. Jupiter and Saturn each have dozens, some barely larger than boulders, others rivaling the size of planets. Titan, Ganymede, Europa, and Enceladus. Icy worlds with seas, atmospheres, geysers, and mysteries of their own. Uranus and Neptune host their own collections of strange frozen moons, many with fractured surfaces or hidden oceans. Out in the cold, gravity gathers companions easily. The farther from the sun you drift, the more moons you find like lanterns, circling giants in the dark. Hubble has photographed planets from its orbit above Earth. Though it circles just a few hundred kilometers above our world, the Hubble Space Telescope has captured astonishingly detailed images of the outer planets. It has watched storms form and fade on Neptune, tracked swirling cloud bands on Jupiter, followed seasonal shifts on Mars, and glimpsed delicate auroras wrapping around distant planets. From its silent vantage point, Hubble provides a decades long record, something spacecraft flybys cannot. It sees weather evolve, impact scars appear, colors brighten and dim. With each image, it reminds us that even the familiar planets are living, changing worlds. Jupiter's great red spot is centuries old. Deep in Jupiter's southern hemisphere spins a storm so large 2 Earths could fit inside it. First recorded in the 1600s, this colossal vortex has raged for centuries, shrinking, stretching, and changing color, but never disappearing. Winds at its edge roar at over 400 kilometers per hour. Its red tint may come from complex chemicals lifted high into sunlight and altered by radiation. While Earth's storms last days or weeks, this Jovian tempest has endured longer than many civilizations. A swirling monument to persistence in a world ruled by storms. Neptune radiates more heat than it receives from the sun. Despite orbiting in the deep cold, Neptune glows with internal energy, releasing far more heat than sunlight provides. This warmth fuels its wild, fast moving winds, the fastest in the solar system, and drives storms that sweep across its blue atmosphere. Scientists still debate the source of this heat, leftover energy from Neptune's formation, slow compression under its own weight, or radioactive decay hidden in its core. Whatever the cause, Neptune is not a quiet ice giant. It is a restless living world, cold on the outside, yet simmering deep within. Earth is the only planet with water in all three states. Here, water flows as liquid rivers and oceans, drifts as clouds and vapor, and rests as ice in polar caps and mountain tops. This delicate balance exists because Earth sits at just the right distance from the Sun with just the right atmospheric pressure and climate stability. Other worlds contain water. Yes, Europa with its buried ocean, Mars with its polar ice comets, with frozen reservoirs, but only Earth displays the full cycle openly on its surface. Water breathes through our world, shifting forms in an endless loop that sustains life. The heliopause marks the edge of the sun's influence. As the solar wind streams outward, it travels billions of kilometers before finally weakening enough to meet the pressure of interstellar space. This boundary, the heliopause, is where the sun's protective bubble ends and the galaxy begins. Voyager 1 and Voyager 2 have crossed this invisible frontier, entering a region where particles come not from our sun, but from the stars beyond. It is the true edge of our solar neighborhood, a quiet threshold where the familiar gives way to the unknown. This boundary is called the heliopause, the final outer edge of the sun's protective bubble, the vast heliosphere that surrounds every planet and moon we've ever known. Beyond this thin frontier, the pressure from distant stars and the drifting particles of the galaxy finally outweigh the solar wind. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018, slipping quietly into true interstellar space. The sun's gravity still extends much farther, but energetically, this is where its influence fades. A last soft exhale before the universe begins in earnest. The solar system itself is drifting through a local interstellar cloud, a subtle, ghost like region of gas and dust about 30 light years wide. It belongs to an even larger structure called the local bubble, carved long ago by ancient supernova explosions. As the sun moves through this cloud at roughly 7,000 kilometers per hour, the heliosphere acts like a protective shield, shaping how interstellar particles flow around us. Scientists study this gentle drift to understand how cosmic rays, magnetic pressure, and the shifting interstellar environment have shaped Earth over time. We are not parked in space. We are sailing slowly through a quiet galactic mist. Some moons are surprisingly alive beneath their icy shells. Geologic activity is not reserved for planets alone. Io, Jupiter's tortured moon, erupts with constant volcanic fire, driven by relentless tidal stretching. Enceladus blasts plumes of water vapor into space from a warm ocean hidden beneath ice. Europa and Ganymede likely cradle vast subsurface seas stirred by internal heat. Even distant Triton, moving backward around Neptune, shows signs of icy eruptions and a shifting, restless interior. These moons are not frozen relics. They are dynamic worlds of chemistry and heat with surfaces that hide entire ecosystems of possibility. Pluto's atmosphere appears and disappears in a cosmic cycle. When Pluto swings closer to the Sun, even by its distant standards, frozen nitrogen and methane warm just enough to rise as vapor, forming a delicate atmosphere that reaches high into space. But as Pluto drifts outward again, the warmth fades and the gases settle back onto the surface in a thin frost. This inhale and exhale unfold over Pluto's 248-year orbit. During the New Horizons flyby, this temporary atmosphere revealed itself as a soft blue haze, fragile, layered, and fleeting around a world that spends most of its existence in deep cosmic winter. Temperatures at the sun's core exceed 15 million degrees Celsius. In that hidden center, hydrogen atoms are squeezed so tightly that they fuse into helium, releasing staggering amounts of energy. This fusion fuels every sunrise, every warm breeze, and every living thing on Earth. Yet the energy born in the core takes hundreds of thousands of years to travel outward through the dense solar interior. Only when it reaches the surface does it stream into space, crossing the vast distance to Earth in just over 8 minutes. The sun looks calm from afar, but inside it burns with unimaginable force. Uranus too wears rings, though they are far more subtle than Saturn's shimmering bands. 13 narrow dark rings encircle the pale blue world, each one tilted along with the planet's extreme sideways orientation. These rings are faint and thin, likely made of dust and icy fragments, but they reveal a quiet complexity in a planet often overshadowed by its brighter neighbors. Set against Uranus's unique tilt, the rings form a slanted halo, drifting with the seasons as the planet slowly rolls along its orbit. Made of tiny particles of rock and ice, Uranus's rings drift in quiet alignment with the planet's unusual sideways tilt. Because Uranus lies almost completely on its side, these rings stand upright in space, appearing vertical when viewed from above the sun's north pole. Some of the rings are astonishingly narrow, clean-cut lines, likely maintained by tiny shepherd moons that guide and sculpt their edges. They remained completely unknown until 1977, when they briefly dimmed the light of a background star and revealed themselves for the first time. Since then, they've been seen as subtle, shadowed bands circling a planet that rolls, instead of spins, an understated halo around a world turned sideways. The heliosphere is a vast magnetic bubble blown outward by the sun itself. The solar wind, a continuous stream of charged particles, flows in every direction, inflating this enormous structure and surrounding the entire solar system in a protective magnetic cocoon. This bubble shields us from a portion of the harsh radiation that drifts between the stars. Shaped by both solar activity and the pressure of interstellar space, the heliosphere stretches far beyond the orbit of Pluto, enclosing planets, comets, and distant icy debris. Its outer boundary, the heliopause, marks the quiet place where the sun's influence fades into the background of the galaxy. As the sun moves around the Milky Way, this magnetic bubble travels with it, carrying our entire solar family through changing cosmic neighborhoods. Mercury's orbit once held a mystery that changed physics. For generations, astronomers noticed that Mercury's closest point to the Sun, its perihelion, drifted slightly with each orbit, shifting more than classical physics could explain. In 1915, Einstein's new theory of general relativity provided the missing piece. Space and time, he said, curve around massive objects. The sun's immense gravity subtly warps the space Mercury moves through, altering its orbit by exactly the amount that puzzled astronomers. This elegant match between prediction and observation became one of the earliest proofs of Einstein's revolutionary theory, revealed through the motion of a scorched tiny world circling too close to the sun. The moon shapes Earth's tides in a constant rhythmic pull. Its gravity draws Earth's oceans toward it, creating a bulge on the side facing the moon and another on the opposite side. As Earth rotates, these bulges move across coastlines, producing the daily pattern of high and low tides. The sun adds its own influence, creating especially strong spring tides when sun and moon align, and gentler neap tides when they sit at right angles. These tidal forces don't just move water, they subtly tug on Earth's crust, slow the planet's rotation over long spans of time, and help maintain the stability of Earth's climate. Quiet and persistent, the moon's pull keeps our oceans in motion, and far beyond Neptune, there may be worlds we have yet to see. Some distant Kuiper Belt objects follow unusual clustered paths, elongated orbits that don't match the gravitational influence of any known planet. One leading explanation is the possibility of a hidden world, often called Planet 9, tugging gently on these remote bodies from the dark. If it exists, this unseen planet would be several times more massive than Earth and orbit thousands of times farther from the Sun, completing 1 year in tens of millennia. We haven't found it yet, but the signatures of something out there continue to tease astronomers, a reminder that even in our own solar system, there are still mysteries waiting in the cold. No direct evidence has confirmed the existence of this hidden world yet, but telescopes continue to search the darkness. If such a planet is eventually found, it would reshape our understanding of how the outer solar system is organized, revealing that even in our own cosmic neighborhood, surprises still wait beyond the edge of sight. Callisto may also hide an ocean beneath its battered crust. At first glance, Jupiter's moon, Callisto, appears ancient and quiet, covered in craters that have gone untouched for billions of years. But beneath that heavily scarred ice, scientists suspect there may be a buried ocean kept liquid by internal heat and lingering warmth trapped since its formation. Measurements from the Galileo spacecraft detected magnetic behavior that hinted at a conductive layer under the surface, consistent with salty water. If true, Callisto would join Europa and Ganymede as another member of the solar system's growing family of ocean worlds, places where chemistry, heat, and time might allow life to take hold in the dark. Venus is hotter than Mercury, even though it sits farther from the Sun. Mercury may be closest, but Venus holds the title, for the most blistering surface in the solar system. Its dense carbon dioxide atmosphere traps heat with extreme efficiency, creating a runaway greenhouse effect that pushes temperatures above 460 degrees, hot enough to melt metal. Mercury, on the other hand, has almost no atmosphere at all. Without insulation, its days scorch and its nights freeze. Venus's intense heat isn't a matter of distance. It's a demonstration of how powerful an atmosphere can be when it locks radiation in and refuses to let it escape. Saturn's rings are made almost entirely of ice. Although they appear solid from afar, Saturn's rings are actually billions of tiny, separate pieces. Flakes of ice, bright chips of frozen water, and the occasional boulder glinting in reflected sunlight. These particles orbit together in a thin, elegant sheet sculpted by Saturn's gravity and shaped by the gentle pull of nearby moons. Gaps, waves, and braided ringlets ripple through the system, each a signature of gravitational interactions. Over time, the rings shift subtly, revealing a dynamic architecture of frozen fragments moving in quiet harmony. Ceres is both an asteroid and a dwarf planet. Found in the asteroid belt between Mars and Jupiter, Ceres is so large and round that it qualifies as a dwarf planet, the only one in the inner solar system. When NASA's Dawn spacecraft arrived, it discovered bright reflective spots scattered across the surface. These turned out to be salt deposits, possibly left behind by briny water that once seeped upward and evaporated. Ceres is a transitional world, not quite a planet, and not a typical asteroid, either an ancient mixture of rock ice and chemistry from the solar system's earliest days. Mars appears red because its surface is coated in rust. Fine dust rich in iron covers the planet, and over billions of years, that iron has reacted with the thin Martian atmosphere, forming iron oxide, the same compound that covers rusty metal on Earth. This dust lifts into the air during storms, colors the horizon, and drapes the landscape in shades of red and orange. Up close, Mars contains darker basaltic plains and bright polar caps, but from space its rusty glow dominates, marking it unmistakably among the planets. Sunspots are cooler patches on the sun's surface. Though still scorching hot, these darker regions appear where tangled magnetic fields inhibit the upward flow of heat. Sunspots can grow larger than Earth and tend to cluster in patterns that rise and fall with the sun's 11-year activity cycle. They are not cold, just slightly cooler than the surrounding plasma, creating strong contrast against the sun's bright surface. These shifting marks offer a window into the sun's magnetic heartbeat, revealing patterns of energy just beneath the surface. Uranus was the first planet discovered with a telescope. Unlike the bright planets known since ancient times, Uranus remained unnoticed until 1781, when astronomer William Herschel spotted it through his telescope and realized it wasn't a star at all. Its slow movement across the sky revealed its true nature, a distant pale giant circling the sun. This discovery expanded the known borders of the solar system for the first time in human history, showing that the night sky still held worlds waiting quietly in the dark. At first, Herschel believed he had discovered a comet, or perhaps a distant star, but continued observations revealed something different. Its motion was steady, planetary, unmistakable, and so Uranus became the first world found with the aid of a telescope, the first planet added to the map of the solar system in modern history. Its discovery signaled a shift from sky watching with the naked eye to a new era of instrument guided exploration. Since then, Uranus has revealed more secrets: a strange sideways tilt, a delicate ring system, and moons carved from ice, and quiet geological stories. It is a world that expanded the boundaries of the night sky almost without trying. The solar system itself is about 4.6 billion years old. By examining ancient meteorites, radiation signatures, and the oldest surviving rocks on Earth and the Moon, scientists have traced our origins back to a vast swirling cloud of dust and gas. This solar nebula collapsed under gravity, igniting the early sun at its center. The leftover material slowly gathered into planets, moons, comets, and asteroids, the scattered architecture of a young cosmic family. What we see today is the calm result of a violent beginning: collisions, migrations, molten worlds, cooling into crusts and fragments that never fully formed into planets. Vesta carries the structure of a small world, second only to Ceres in size. Within the asteroid belt, Vesta isn't just a rock, it's a protoplanet. Beneath its rugged exterior lies a layered interior, a metallic core, a mantle, and a crust much like the terrestrial planets. This means Vesta once burned with enough internal heat to melt and separate into distinct layers. The enormous Rhea Silvia Basin at its south pole exposes some of these ancient depths, the scar of a massive impact. Vesta is a planetary embryo that never grew up a frozen witness to how worlds are built. The moon itself quakes. Though silent from afar, the moon occasionally trembles with moonquakes. Some are triggered by Earth's tidal pull, others by the expansion and contraction of the lunar crust as sunlight warms it and darkness cools it again. A few originate deep within the moon, slow and persistent, sometimes lasting nearly an hour, far longer than typical earthquakes. Instruments left by Apollo first revealed these subtle vibrations, reminding us that even without plate tectonics, the moon is not entirely still. Beneath its dusty surface lies an interior with a faint lingering pulse. Triton is a moon that Neptune did not make. Orbiting backward relative to Neptune's spin, Triton's retrograde motion is a giveaway. It was captured, not formed in place. Once likely an icy body from the Kuiper Belt, Triton was drawn into Neptune's gravity long ago, disrupting the planet's earlier moons and reshaping itself through intense tidal heating. Now, geysers of nitrogen erupt from beneath its surface, staining its thin atmosphere and decorating its crust with strange textured plains. Triton is a wandering world, forced into orbit, a relic of the outer solar system held in an adopted embrace. Neptune has at least 14 moons. Far from the warmth of the sun, Neptune is accompanied by a scattered collection of icy satellites. Triton is the dominant one, but the others, Proteus, Nereid, Naiad, and more, follow eccentric and sometimes chaotic paths. Many are dark, irregular bodies likely captured from the Kuiper Belt. Together, they form a quiet, distant family circling a planet whose winds howl faster than anything else in the solar system. Their orbits preserve hints of Neptune's dynamic and turbulent past. The Parker Solar Probe is now brushing the edge of the Sun itself. NASA's Parker Solar Probe is the first spacecraft ever to plunge directly into the Sun's outer atmosphere. Protected by a heat shield that endures temperatures hotter than molten lava, Parker flies closer with each orbit, sampling plasma tracing magnetic fields and touching regions once thought unreachable. Its mission is to understand why the sun's corona is so much hotter than its surface, how solar wind is born, and what drives the storms that ripple across our solar system. It is humanity's own fingertip extended toward a star, a vessel skimming the fires that shaped our world. Launched in 2018, NASA's Parker Solar Probe became the first human made object to dive straight into the sun's outer atmosphere, the shimmering superheated corona. It moves faster than any spacecraft ever built, slicing through space at extraordinary speeds while enduring temperatures that soar beyond 1,000 degrees Celsius. Wrapped in an ultra resilient carbon composite shield, Parker slips a little closer, with each orbit sampling solar wind, tracing magnetic fields, and feeling the bite of high energy particles as it sweeps past. Its mission is to answer questions that have puzzled scientists for generations. Why is the corona so much hotter than the surface below? How do solar flares hurl charged particles across billions of kilometers? In a very real sense, Parker is not merely observing the sun, it is flying through it. Some meteorites that fall to Earth began their journey on Mars. Long ago, powerful impacts struck the Martian surface, launching fragments of rock into space. These pieces drifted for millions of years before crossing Earth's orbit and falling through our atmosphere. We know they are Martian because their chemistry matches measurements taken by rovers and orbiters on the red planet. Some even hold tiny bubbles of trapped Martian air. Within them lie clues to water, ancient minerals, and geological stories that unfolded on Mars long before humans ever looked up at the sky. They are messages from another world delivered by nature itself. The sun is made almost entirely of hydrogen and helium. About 70% of its mass is hydrogen, with most of the rest being helium, the two lightest elements forged in the earliest moments of the universe. Under the crushing pressure of the sun's core, hydrogen atoms fuse into helium, releasing the energy that warms our world and lights our days. Only a tiny fraction of the sun is made of heavier elements such as carbon, nitrogen, and oxygen. Yet within that simplicity lies a furnace powerful enough to shape the entire solar system. Earth's tilt is what gives us seasons. Our planet spins while leaning at about 23.5 degrees relative to its orbit. This tilt causes sunlight to strike each hemisphere differently throughout the year. When a hemisphere tilts toward the sun, its days grow longer and its sunlight stronger summer. When it tilts away, the light arrives at a lower angle and the days shrink winter. Without this tilt, Earth would have no real seasons, and much of the planet's climate would be uniform and unchanging. Over long spans of time, the tilt slowly shifts due to gravitational nudges from the moon and other planets, but its steady influence remains one of the quiet forces shaping life's rhythms. Jupiter's magnetosphere is the largest structure in the entire solar system. Its magnetic field swells outward for millions of kilometers, forming a bubble so enormous that if visible, it would outsize the Sun itself. This field originates from deep within Jupiter's interior, where metallic hydrogen conducts electric currents strong enough to sculpt space. Inside this vast magnetosphere, charged particles race along magnetic lines, generating intense radiation belts and colossal auroras that flare above Jupiter's poles. Volcanic material from Io feeds into this system, creating a swirling, electrified environment that can overwhelm unprotected spacecraft. It is magnetism at an astonishing scale. Planetary rings may be only temporary guests. Though they appear serene and eternal, the rings surrounding Saturn, Jupiter, Uranus, and Neptune may last only a brief moment in cosmic time. Rings form from shattered moons, icy debris, or fragments pulled into orbit. But over millions of years, these particles drift inward through gentle collisions, gravitational tugs, and magnetic drag. Saturn's rings, for example, may be no older than 100 million years, and they may disappear in another 100 million. What we see now is likely a fleeting chapter, a shimmering display in the long life of a planet. The moon's surface barely changes across ages. Without wind, rain, or active geological cycles, the lunar landscape is almost frozen in time. Craters remain sharp for eons. Dust lies undisturbed. Even the footprints left by Apollo astronauts will remain etched into the regolith for thousands, perhaps millions of years. On the moon, silence is not just the absence of sound, it is the absence of change itself. Launched in 2018, NASA's Parker Solar Probe became the first human made craft to plunge directly into the sun's outer atmosphere, the shimmering superheated corona. It travels faster than any spacecraft in history, slicing through space at astonishing speeds while enduring temperatures that climb well beyond 1,000 degrees Celsius. A carbon composite heat shield stands between the probe and the sun's fury, allowing it to slip a little closer, with each orbit dipping into regions once thought unreachable. There it measures magnetic fields, samples the solar wind, and feels the sting of high energy particles as they stream outward. Its mission is to unravel long standing mysteries, why the corona blazes so much hotter than the surface below, and how the sun hurls bursts of charged particles across billions of kilometers. In a quiet, extraordinary way, Parker is not just observing the sun, it is flying through it. Some meteorites on Earth began their journey on Mars. Though the red planet lies millions of kilometers away, fragments of it have landed on our world. Powerful impacts on Mars long ago blasted stones into space, sending them drifting through the solar system until a few eventually fell into Earth's atmosphere. We know their origin from the chemistry locked within them, gases identical to the Martian air minerals shaped by ancient water and signatures that match measurements taken by rovers and orbiters. These meteorites are natural samples from another planet delivered to us by cosmic chance long before humanity learned how to return the favor. The Sun is made almost entirely of hydrogen and helium. Roughly 70% of its mass is hydrogen, with most of the remainder being helium, the two simplest elements in the universe. Under the scorching pressure of the Sun's core, hydrogen atoms fuse into helium, releasing the light and heat that fill our skies. Only a small fraction of the Sun consists of heavier elements such as oxygen, carbon, and nitrogen forged in stars that lived and died before our Sun was born. For all its brilliance and complexity, the Sun is fundamentally a glowing sphere of ancient gas shaped by gravity and nuclear fire. Earth's tilt is the architect of our seasons. Our planet leans at about 23.5 degrees relative to its orbit, and this gentle tilt changes how sunlight touches each hemisphere throughout the year. When a hemisphere faces the sun more directly, days stretch longer and sunlight strengthens, summer arrives. When it leans away, sunlight softens and days shrink, winter begins. Without this axial tilt, Earth would know little seasonal change, and climates across the globe would be far more uniform. Over long spans of time, gravitational nudges from the moon and the planets cause this tilt to shift slightly, but its influence remains steady, shaping the rhythm of life year after year. Jupiter's magnetosphere is the largest structure in the entire solar system. Its magnetic field swells outward for millions of kilometers, creating a bubble so vast that if it glowed visibly, it would appear larger than the sun in our sky. Generated by currents flowing through Jupiter's deep layers of metallic hydrogen, this magnetosphere traps charged particles, forms intense radiation belts, and fuels enormous auroras that flicker above its poles. Volcanic material from Io is swept into this magnetic web, electrifying the environment and making the region around Jupiter one of the most hazardous places for spacecraft. It is planetary magnetism at its grandest scale, powerful, intricate, and full of energy. Planetary rings may be only temporary. Though they look timeless, the elegant rings of Saturn, Jupiter, Uranus, and Neptune are likely short lived on cosmic scales. Rings form from shattered moons, icy debris, or leftover fragments drawn into orbit, yet these particles gradually drift inward over millions of years through collisions, gravity, and magnetic drag. Saturn's rings, for example, may be no older than 100 million years, and they may fade entirely in another 100 million. What we see now is a rare, shimmering moment, a bright chapter in a planet's long and quiet life. The moon's surface barely changes through time. Without wind to shape it, rain moan, to erode it, or active geology to renew it, the lunar surface remains frozen in silence. Craters linger for billions of years. Dust settles and stays. Even the footprints left by Apollo astronauts will remain preserved for many thousands, possibly millions of years. On the moon, stillness is not just peaceful, it is permanent. Auroras, those soft veils of green, red, and violet that shimmer near Earth's poles, are born from a dance between the sun and our planet's magnetic shield. When charged particles from the sun stream outward and collide with Earth's magnetic field, they spiral downward toward the poles and ignite the sky with light. These displays wax and wane with the sun's 11-year activity cycle. During solar maximum, when sunspots multiply and flares erupt more frequently, more particles race toward Earth, and the auroras intensify, glowing with energetic colors that ripple across the night. In quieter years, during solar minimum, the lights retreat into softer, gentler glimmers. Every aurora is a reminder that space weather travels across millions of kilometers to brush faint strokes of color across our sky. A comet's tail always points away from the sun. When a comet approaches the inner solar system, sunlight warms its icy surface, releasing jets of vapor and dust that form a luminous tail. But the tail doesn't necessarily trail behind the comet's motion. Instead, it is pushed outward by the solar wind and radiation stretching away from the sun, regardless of the comet's direction. This creates two distinct tails, a broad curved dust tail and a narrow bluish ion tail. Together, they trace the invisible pressure of sunlight, a glowing banner unfurling in the dark. Some moons were forged by catastrophic impacts. Our own moon likely formed when a Mars-sized body struck the young Earth, ejecting molten debris that eventually gathered into a single orbiting sphere. Pluto's moon, Charon, may share a similar origin. Other moons, especially those of the gas giants, were captured from wandering objects or born from disks of material swirling around their planets. Some came from fire and collision, others from slow gravitational shepherding. Their diverse beginnings echo the turbulent creativity of the early solar system. Voyager 1 carries a golden record into the dark between stars. Launched in 1977, Voyager 1 is now farther from Earth than any spacecraft ever built, drifting through true interstellar space. Bolted to its side is the golden record, a copper disc plated in gold containing greetings, images, songs, and sounds meant to describe life on our planet. Waves crashing, birds calling, music from across cultures, human laughter, curated by a team led by Carl Sagan. It is a gift to the cosmos, a small, hopeful message from Earth carried outward on a spacecraft the size of a small car, sailing beyond the reach of sunlight. Earth shares its orbit with quiet co-travelers. Though Earth has no second moon, it does share its orbital neighborhood with a handful of co-orbital asteroids. These objects don't orbit Earth itself. Instead, they move around the sun in patterns shaped by Earth's gravity, looping horseshoe paths, gentle arcs, or Trojan positions that stay ahead of or behind our planet. Many are temporary companions, caught for a few thousand years before drifting away again. Unseen by the naked eye, they travel with us silent neighbors, accompanying Earth on its long yearly journey. Neptune was once mistaken for Uranus. Before Neptune was formally identified in 1846, astronomers repeatedly observed it, but often assumed it was a star or merely another measurement of Uranus itself. Its slow movement and dim appearance made it easy to overlook. Only when mathematicians noticed oddities in Uranus's orbit, subtle deviations caused by the gravity of another unseen world did they calculate where Neptune should be. And when telescopes finally pointed to that predicted place, a new planet waited there, exactly as the math foretold. Some early astronomers may have looked straight at Neptune without ever realizing its true nature. Because it creeps so slowly across the sky and shines so faintly, it was often logged as a dim star or mistaken for a repeat sighting of Uranus itself. Even Galileo in 1612 may have unknowingly sketched Neptune as a fixed point of light, unaware that the star he drew was a distant planet wandering through the darkness. For centuries, it hid in plain sight, a slow moving ghost woven into the tapestry of the night sky, waiting for mathematics, not eyesight, to reveal its identity. The edge of the solar system isn't a wall where gravity stops. The sun's gravitational reach extends astonishingly far, holding distant comets and icy fragments in the Oort cloud potentially halfway to the next star. But when we talk about the edge of the solar system, scientists usually mean the boundary of the heliosphere, the region where the solar wind finally weakens and merges with the interstellar medium. This frontier, the heliopause, isn't a hard border, but a gradual shift in pressure where the breath of the sun fades and the environment of deep space begins. Gravity persists far beyond, but its energetic shield ends here. All planetary atmospheres slowly drift away into space. Even Earth's thick blanket of air isn't truly sealed. Light gases like hydrogen and helium escape over time, slipping past gravity and vanishing into the void. This process, known as atmospheric escape, is even more dramatic on smaller worlds like Mars or Mercury. Venus, lacking a protective magnetic field, has had parts of its upper atmosphere stripped away by the relentless solar wind. Earth loses thousands of tons of hydrogen each year, an imperceptible leak, steady, an ancient part of the quiet exchange between planets and the vacuum around them. Some moons may have been born from the remains of rings. Just as rings can erode and disappear, they can also gather themselves together into small moons over time. Around Saturn, several of its tiny outer moons might have originated from icy ring particles that clumped together beyond the Roche limit, the boundary where gravity allows material to coalesce rather than be torn apart. Moons like Pan and Daphnis, which glide within Saturn's rings, still shape the icy bands today, carving grooves and waves with their delicate gravitational pull. They are sculptors made of rock and ice, giving form to a shimmering world. Voyager 1 continues to speak to us from interstellar space. More than 45 years after leaving Earth, the spacecraft still sends faint signals home, even as it drifts through the thin, quiet plasma between the stars. Its power is fading, and instruments have been slowly shut down to preserve what remains, but it still measures cosmic rays, magnetic fields, and the densities of the interstellar medium. It runs on a small nuclear generator, whispering data across the deep space network. Each message takes more than 20 hours to return to Earth, a soft echo from humanity's most distant explorer. The solar system circles the Milky Way every 225 million years. While Earth revolves around the Sun itself is on a much grander journey orbiting the center of our galaxy. One complete circuit, a galactic year, takes roughly 225 to 250 million Earth years. During that immense span, the solar system drifts through varying regions of the Milky Way, dense star forming zones, gentle interstellar clouds, and spiral arms rich with dust. These transitions may subtly influence comets' cosmic radiation and possibly even long term climate patterns on Earth. We are not stationary. We are passengers riding a spiral arm moving through the galaxy on a slow ancient carousel. And now we gently drift toward the end of tonight's cosmic wander, from worlds baked in sunlight to frozen moons humming beneath their shells. We've moved together through vast orbits, silent storms, and the soft machinery of the sky, step by unhurried step, fact by peaceful fact. If your eyelids are beginning to sink, let them. You've already traveled farther than most people journey while awake. Let the remaining stars dissolve into a quiet blur. Let your breathing slow, as if you're floating in the dark between planets, weightless, unbothered, held by the calm of the universe. There will always be more mysteries waiting for you, more rings, more moons, more distant worlds whispering through the dark, but none of them require your attention tonight. You've gathered enough wonder for one evening. Thank you for drifting through the solar system with me, for letting these gentle stories be the last thoughts of your day. As the night settles and the sky stretches out around you, allow yourself to rest fully, knowing the cosmos will still be here when you wake. So, under this quiet canopy of stars, let sleep arrive like a soft tide. Rest deeply, dream kindly, and until our next journey, good night.